What is going on, guys? And in this video we are going to solve this amazing and kind of long exercise about rational numbers. Okay, so that's what we are going to do. We are going to write down, here are the instructions, write down a struct called rational, and this struct should basically represent a numerator and a denominator. And this struct should also kind of simulate the operations, or basically not the struct itself, but for this point in time we will use separate functions that should get and work on various rational struct variables. So that's what we are going to do. And now let us start. All right. So I hope, first of all, that you tried to solve this exercise on your own. It's very important and very crucial to your understanding. Can you hear me? Right? So now, after you've tried it on your own, we are going to do that together. So first of all, we need to create the structure itself. And the way we do that is simply by writing down the following line. Type def struct rational, specifying the fields of this structure, and the fields are going to be as following. There is the numerator and there is the denominator. So it's going to look like this if I'm going to get my awesome pen. So basically every rational number is going to look like this. So this is a rational number. You're also getting math much better after my tutorials. So this one here is basically the numerator, and this one is the denominator. Okay, so two fields representing a rational number. Awesome. So a variable of the rational number is basically going to have these two fields, and they are kind of representing this structure. Okay? Good. So let us start working with the functions. And the first function that they asked us to make is the increment function. So if we want to write down a function that should work on a rational variable and increment it by 1, we first of all need to understand the process of working with increment. And the way to do that is simply writing down increment. So before I write down the implementation, as I already told you, write down on a piece of paper the main steps that you want to follow in order to complete this process. Okay, you following? Awesome. So we want the following operation. We want to take some rational number and simply adding 1 to it. That's the default increment that I'm going to use. So basically, just before we move on to this increment, this note I gotta say to you explicitly. So in this case, when we are going to work on this basic, let's call it structure of numerator and denominator, well, for simplicity, we will assume that both the numerator and denominator are greater than 0. Okay, I'm not going to dive into all the details of what happens if both of them are less than 0, or if any of them equals to 0, or if any of them is a negative. So for now, let's assume for simplicity, okay, that both of them are 0. Okay, so write down this note. Awesome. So what we need to do now is to understand what is the result, first of all, on paper of this operation. It's not going to be like if you take 1 divided by 3, okay, 1/3, and you add 1 to it, the result is not 2 divided by 3. That's not it. What you do is you do some common ground, common denominator, okay? So basically you expand this value to be represented as, for example, the denominator. This is d, this is n, okay? N for numerator and d for denominator. So this will look like this, n divided by d plus d divided by d, right? D divided by d, denominator divided by denominator, is the same number. We just represent the value of 1 as a whole as simply denominator by denominator, this one. And this will allow us, basically, now when both of our rational numbers have the same denominator, we can write the result as numerator plus the denominator. This will be the result. So, for example, if we come again to this question, okay, we can say that the final result will be what? The denominator, which is 3. It will be 1, the numerator, plus 3. So the final result should be 4 divided by 3. Okay? That's the basic way to work with incrementation by 1. So now that you realize what you have to do on paper, oh, sorry, I think I have covered this solution, so let me get it like that. Okay, so this is it. This is the solution right here of the incrementation. So let me write it down a little bit above. Okay, so yeah, sorry about that. I was basically covering everything. So increment is basically the result should be like numerator divided by denominator plus 1 equals to what? To n plus d divided by d. Okay, hopefully this is clear to you. If not, feel free to ask any questions. And we gave a couple of examples. Also, if we give another example, let's say 2 divided by 5 plus 1 will be equal to 5. And we take 2 divided by 5 plus 5 divided by 5 is 1. So that will be the result, 7 divided by 5. Basic math. Okay, so now let's take a look at the function implementation. So we are going to uncomment this part. Okay, and well, let's also remove this one. We already know it. Okay, good. So we are going to make a function of a void type because we do not expect this function to return anything. So we are going to call it rational increment. It's going to get an address of some existing rational variable. And then we are going to say that the result numerator, okay, that the result numerator will be equal to the numerator itself that we take. This is it. And also we are going to add to it its denominator. Okay, so numerator plus denominator. That's what we are going to do. That's basically what we do. So let's take another example. Let's take a look at this example. We have here, first of all, this is our rational object, rational variable. It has the numerator of 2 and the denominator of 5. And then we say that the result is going to be the previous numerator plus the denominator divided by the numerator. That's what it's going to be. So we can say that this function is over, it's done. So one question for you is how you can call this function. And you can call this function in a very simple way. You can simply write down, then when you are going to check out in the main function, you can write down, create some rational number. So create rational R1 with, I don't know, 1 and 3 values. Okay. And then what we are going to do is simply make this function call as rational increment and then specify here the address of R1. That's what we are going to do. So now if we take a closer look, then what we will see that after this line, what basically has happened is that we increased this value to be 4 divided by 3. That's everything about rational increment. Awesome. Now if we take a look at the next one, which is decrement, it's going to be pretty much the same. Okay, we are simply going to expand it a little bit, and we are going to say that the numerator equals to the previous numerator minus the denominator. So it's going to look like this. it's going to look like this. It's going to look like 1 divided by, or let's say 3 divided by 5. Let's give another example of 7 divided by 4 minus 1. It will be equal to 7, all of it divided by 4, minus 4. And the final result will be 3 divided by 4. Okay, that's it. So that's about the decrement operation, very similar to the increment. It will be called, the calling to this function will also be very similar. Okay, so I hope it's clear. And both of them of these functions were basically of a void type, since we do not return anything. We work on the same variable, so we send the address of this variable. Later on, we have this addition function. And this addition function basically receives 2 rational variables, calculates the addition of both of them, and returns the result. So what you need to understand is whenever you are going to work with 2 rational numbers, let's say we will call the first one n1 divided by d1, which is numerator 1 divided by denominator 1. This is the representation of just one rational number, and we want to add to it another rational number, n2 divided by d2. So the way you do it is not just like this, n1 plus n2 and d1 plus d2. That's not how you do it. Okay, that's not, basically, it's not something that I have invented. That's math. Okay, so there are strict rules that we should follow. And how it's going to look like? First of all, we do some common ground, some common denominator. And the common denominator of the result, okay? This is the first rational number, r1. This is going to be r2. And this is going to be the final result, okay? So the final result denominator is going to be d1 multiplied by d2. And the numerator of the result is going to be n1 multiplied by d2 plus n2 multiplied by d1. That's math, ladies and gentlemen. Okay, so we create a variable called result of rational type. This variable has fields, denominator and numerator. So we will calculate the result field. Result.denominator will be equal to r1.denominator multiplied by r2.denominator. This is it. This is this part. And also we calculate the numerator. How do we do it? We say result.numerator, which is this part, will be equal to r1 numerator, which is n1, multiplied by r2 denominator, which is d2, plus r2 numerator multiplied by r1 denominator. And then we calculated the result numerator. That's math. Once again, math, math, math. There are rules for working with rational numbers. We just need to understand them and then to use these rules and construct and create and develop different functions in our programming language. Okay? So that's it about rational addition. And we return, the return type is rational because we return some value which is of type rational, some variable. I'm not talking about, in this example, whether it will be if it will be better to use here a pointer or references and so on. It doesn't matter, okay? For now, let's use it as simple as this, just to demonstrate the usage of these functions. Okay? Good. So the function call itself for this part is going to look like this. Let me just show you. The function call is going to look like this. Okay, suppose that you have created rational r1, which will be equal to 1, 3, and r2, which will be equals to 2 and 5. So then the result, you will create rational r3, will be equal to what? To rational addition of who? R1 and R2. That's it. And then in R3, there will be the result of the addition between these two rational numbers. Okay? Whew. I hope you're following me so far, because we are just getting like one after the other, but it's very important for you to understand each and every step here, so you can feel free to stop this video, watch it once again, and then replay it, and so on. Okay? Awesome. So, this part is over, but we are not done yet. There are additional 7 functions that we need to follow. So let's go over them quickly. The next one is basically the subtraction. So what we do here is basically we do a subtraction operation. We take R1 minus R2. Also a mathematical operation, very, very similar to addition operation. We simply take two rational numbers, and one d1 minus n2 d2, and the result is very simple. It is d1 multiplied by d2 and n1 multiplied by d2 minus n2 multiplied by d1. That's exactly what we've written here. This is n1. This is, what is it? d2, right? n1 multiplied by d2. This is n2. This is d1. So n1 multiplied by d2 minus n2 multiplied by d1. That should be the numerator of the result. And regarding the denominator, it should be d1 multiplied by d2. And that's exactly what we can see in this line, 3, 8, 6. d1 multiplied by d2, returning the result. Okay, so this is it about subtraction operation, and the function call is very similar to this one. Just like this, instead of rational addition, you simply write down rational subtraction. Okay, then you use multiplication. So in multiplication, that's very, very simple. You simply take, if you need to multiply, let's say, one rational number by the other, then the result is very simple. It should be n1 multiplied by n2, n2, and divided by d1 multiplied by d2. That's it. And that's exactly what we do here. We get two rational numbers, r1 and r2, multiply the denominators, putting it into result.denominator, and also we multiply the numerators, and then put the result into the numerator field. That's what we do. Awesome. So let's proceed. Now we have the division. Division operations. Very, very, very similar to multiplication, just that it works a little bit different. So we have n1 divided by d1, and we try to divide it by n2 divided by d2. So the result of this is basically n1 divided by d1 multiplied by what? By d2 divided by n2. Okay, we simply flip this rational number when we use division, and then we use simply multiplication. So the answer to this is going to be n1 multiplied by d2 divided by d1 multiplied by n2. So the denominator is going to be d1, denominator 1, multiplied by numerator 2. And the numerator of the result is going to be numerator 1, multiplied by denominator 2. Okay, very, very simple. We could also take advantage of using rational division by simply flipping one of them, okay, the second one, and then calling the rational multiplication between the flipped one and R1, but let's keep it simple. That's also an option. I'm not saying no, but for now, that's the way we solve it. Let's move on. We have a little bit left. So, yeah, I think most of them are the same, pretty much the same, so it will be easier to explain. So in this function, what we want to do is to kind of simulate the comparison of if R1 is smaller than R2. So we call this function smaller rational. And what we want to do is to ask a simple question. If one rational number, okay, R1, is less than another rational number, R2. That's what we want to do. So how you would do it? You do not simply ask if n1 is smaller than n2 and d1 is smaller than d2. That's not how you compare who is greater and who is smaller using rational numbers. Once again, these are math rules. That's not something I've invented. Okay? So okay, so what we have to do in order to give an answer to this question is to make for both of them some common ground. Okay, there are also additional ways that we can do it, additional techniques, but I'm going to show you some basic technique. So we make a common ground for, oops, why did it become bigger? So we take this number and we represent it by doing the following. Okay, let me just make it smaller so everything will fit. So n1 d1 and n2 d2, assuming that we know that all of them are positive. Okay, so what we ask is the following question. We want to represent it as this. We want to say n1 divided by d1, and we will multiply it by d2 divided by d2. We can do it, right? Because the value of it is 1, and multiplying any value by 1 will not change the value itself, right? And we do on the same side here pretty much the same, just we multiply by d1 divided by d1. Okay, also that's just 1. We can do it. So n1 multiplied by d2 divided by d1 multiplied by d2. And then we take a look here and we see n2 divided by d1 multiplied by d1 and d1 multiplied by d2. That means that here we have common denominator. We have a common denominator. And once we have a common denominator, we can decide which of these rational number is greater or smaller just by comparing the numerator. Okay, just by comparing these parts, we can decide who is greater. So that's exactly what we've done here in these lines. We calculated the R1 denominator, R2 denominator. Okay, we simply expanded it. And representing now this is R1, and it has the same value as here, just in a different representation. And this is R2, the same as here, just differently represented with the same denominator for both of them. So what we do now is simply ask if this updated numerator, which is n1 multiplied by d2, this is it. It has been updated right here. Okay? If it's smaller than this one, return 1. If it's not, return 0. 1 means that R1 is smaller than R2. 0 means that it's not smaller than R2. That's it. Okay? And the way you call this function is simply you write down smaller rational R1, R2, basically on some two rational numbers that you use, and that's it. And in a very similar way, you do the same for finding out larger rational. Okay, let me simply remove it from here. Very, very simple, very, very similar. I simply copied it from the previous one and just changed this sign. That's what we want to check out. Now is simply instead of this sign, we are looking for this sign. That's it. Of course, there are other techniques that you can solve it. This one, I think, is not the most complicated, hopefully. So let me know if you have any suggestions. But either way, this is good and this is good. And now we can proceed to the last one, which are also very, very similar. These are the equality and not equality signs. So once again here, whenever you want to check if two rational numbers are equal to one another, that's not enough to ask if just the numerator equals to the other numerator and the denominator equals to another denominator. Okay, although that's one option, but we can also say that these two rational numbers, 4 divided by 2, and let's say 8 divided by 4, they are also kind of the same. Okay, right? Because this is 2 and this is also 2, if we take a look at it. So this way, we kind of also solve this problem. And finally, the is not equal rational can also be very similar to this one. We simply make some common ground, some common denominator, and compare between the new, updated, and extended numerators. That's what we do. So we are done with these functions. And now what you need to understand is that, first of all, to make sure that everything is clear in terms of math, then that everything is clear in terms of the functions' names and their purposes and their types and what they receive and what they return and so on. And lastly, understand that this exercise can also be extended, and we can add like operations like flip a rational number, and then we can also add like a function called reduce to simply, if we have this value, okay, instead of keeping it this way, we can reduce it to be like 1 divided by 3. But that's not for this video. That's something you can do also on your own, or maybe we will do in another video. Not sure about it, probably not. But yeah, this is it for it. Write down the main function, make some plays with various rational numbers, make sure that you can call these functions, that they work appropriately, and let me know if you have any questions. I hope you liked this video. This was a very comprehensive solution that took us some time. I don't know how much time, but it took us some time. I think it was about half an hour, but we covered up a lot of things. So once again, guys, I hope this effort will pay off and that you will find this information useful. Please let me know if you liked this video, if you have any suggestions, if you have any questions. Leave some feedback, some review. That helps me a lot, keeps me kind of wanting to work more and to give you more value and more content, more updates, and so on. So thank you guys. My name is Vlad. Keep on practicing, keep on moving forward, and you are bound to succeed. I'll see you next time.